Technical drawings are the language of engineering. They'll tell manufacturers how to make a part, inspectors how to check it, and engineers how everything fits together. Ultimately, if you want to communicate your design clearly, mastering technical drawing is a must. Since we want to create a technical drawing that's clear, complete, and professional, we'll focus on the tools and features you actually use when making one in SolidWorks. Don't worry, we'll go through everything step by step so you'll understand exactly what each feature does and how to use it effectively. Originally, I planned to cover everything about technical drawing in a single video, but there's just so many important stuff to go over that I decided to split it into two parts. So in this video, we'll learn about setting the views, section view, detail view, ballooning, bill of material, and dimensioning. And we talk about important stuff like tolerance and GD&T, title block, drawing options and settings, notes, and break view in the next session. So let's get started and create technical drawing for the model we've been working on throughout this beginner's tutorial series. In engineering, not all drawings are the same. Each type tells a different part of the story. Assembly drawings show how pieces of your design fit together and work as one system. Detailed drawing, on the other hand, zoom in on a single part. They define the shape, size, and critical dimensions so it can be manufactured and inspected properly. So let's create a new document. If you go into advanced mode, you'll see any sheet format you saved in SolidWorks so you don't have to create a new one every time. We'll learn how to create our own specific sheet format, but for now, let's go back, select drawing, and confirm our choice. The sheet size you choose depends on your model's complexity and in case of assemblies, how many parts it contains. If a part is very detailed or has lots of features, you may need larger sheet like A3, A2, A1, or even A0. For our model, A4 will work fine, but I want it in landscape orientation. So select Browse and purchase A4 Landscape, open and confirm it. So the first sheet is always the assembly drawing. In a drawing, there are several key sections. Down in the bottom right corner, you'll find the title block. It is part of the sheet format and it contains information about the designer's name, drawing date, part name, company logo, tolerance details, and the standard being used. Next, there is a revision history table on the top right corner. It lists any changes or updates made to the drawing over time. And finally, the main drawing space where the views of your component or assemblies are displayed. But first thing first, we should specify the standard is going to be used in our drawing. If everyone used their own way of dimensioning, projecting, and tolerancing a part, the result would be confusion, errors, and wasted time. That's why standards like ISO and ASME come in. They define how drawings should be organized, labeled, and interpreted so that anyone, anywhere can understand exactly what's being designed or manufactured. ISO stands for International Organization for Standardization and is based in Switzerland and used in Europe, Asia, and most of the world. It defines first angle projection as default, which means it places the top view below the front view and the right view on the left. ASME stands for American Society of Mechanical Engineers and is based in United States and primarily used in North America and few other regions. It defines third angle projection as the default, so ASME drawings place the top view above the front view and right view on the right. You can set up the drawing standard and projection method right from the sheet. You need to right-click on the sheet and go to the properties. Under type of projection, if you select the first angle, it means you are following the ISO standard. For the ASME standard, select the third angle. You also find few other things here too. For example, the default sheet scale, which defines the scale that applies to any view you insert into the drawing. I leave mine set to first angle projection following the ISO standard, but if you want to select the third angle, be my guest, the learning process is exactly the same for both. Now it's time to set up the views, and for this, go to View Palette and browse for your part or assembly. And let's open it. So here are all the views of your model, front, right, top, isometric, diametric, trimetric, or isometric exploded. And I usually start with the view that it shows most of the details. And for this, I drag top view into the environment. As I move my cursor, you can see other views appear automatically. Each view you want to insert, just click once to insert it. I bring the left view and front view. For most parts, 3 views are enough, but if you want to show more detail of your model, I would recommend you, instead of adding extra views, use detailed views or section views or break views, which we'll learn how to work with them. So I click on OK. I think they are still small for our sheet paper, so let's go to the properties again. I thought I'd set it for 1 to 1. I need to set it to 1 to 2 and confirm it. The first view you import into the drawing is the parent view, and the views taken from it is the child view, which means they following the parent for their properties. If I move the parent view, the children move with it, but if I move the child, the parent doesn't move at all. And in their properties, the child properties, you can see a repetitive checkbox, use parent style or use parent scale. And I usually activate them because I want them to be exactly the same as the parent. That means if I change the scale of the parent view, use custom view and change it to 1 to 5, the others update with it. But if I, for example, change the scale of the child view and use, for example, 1 to 5, the others don't change at all. So let's set it back to use parent scale. So in case you didn't notice, the views are totally aligned. If you want to break the alignment between them, you need to right click on the view and from alignment, break the alignment. And it is moving regardless of the others. And if you want to bring back the alignment, right click on it and from alignment, and this one is align horizontal by origin, click on it and select the parent. So if you want to give more specific, the best option is to create a section view. From drawing, select section view, and in the cutting line, set it to vertical. I want to create a section exactly at the center of the model, and the magnet helps me align it. So click, confirm. You don't need to change anything about this window. It's mainly used when you want to create sections for specific parts only. So confirm it, and place it at the appropriate distance from the view. And just remember that the direction of the arrows always needs to point towards the section view. For example, if the section was on the other side, I needed to click on these arrows and flip the direction. Alright, so if you want to have a better imagination of what you're seeing in this section view, you can right click on the view and open the assembly. So let's collapse the exploded view. And I tiled the part to left and the drawing to right. Now I hit the space on my keyboard and select the top view. Now let's rotate till I see the view that I actually see in the drawing. And let's create a section and I set it on the right plane. It's weird that it is not at the center of the environment. Anyway, set it at the center of the environment, and since the arrows are from right towards left, it means that we are seeing the part from right, so the left parts remain, and I need to flip the alignment and confirm it. Now if I rotate my view and change the display style to hidden lines removed, I can see what I exactly see in the section view. Anyway, now we should add center lines and center mark. A center line represents the axis of symmetry for a part or a feature. So from annotation, select center line, and for example I need to select these two holes. And I don't have anything else, confirm it. Center mark marks the center of the circle. It helps to easily locate the center for dimensioning. So select it, and I need to select this one and this one, confirm it. Anyway, since this top view and right view don't give much of a detail, it's better to delete them. Now it is my two main views, and let's see what else we can add from view palette. Refresh. I think the isometric exploded will help a lot, so I drag it into the sheet. Oh yeah, that helps a lot. Actually, we can see things here that were barely visible within other views, for example these 4 screws or the gear inside the other parts. Now another thing I usually do is to import the isometric view itself. This one gives a good overall idea of what the final assembly looks like. So I place it down here. And the display style, I usually set it to shaded with edges. In the drawing, we have few rotating tools, and the first one is rotate view. So click on it and select the view that you want to rotate. Here we have two check marks that they determine whether the dependent views like the section view rotate with it or not. So you see two checkboxes here which determines whether the dependent views like the section view rotate with it or not. So let's rotate it, for example, 90 degrees. And you can see the section view rotate with it as well. I can hit Ctrl Z to go back to the original position. And for example, if you don't want the dependent view rotate with it, just uncheck these two boxes here. The next tool is 3D drawing view. Select it and select the view. With this tool, you can rotate the model in 3 dimensions. Moving on to ballooning. In drawing, a balloon is a notation that points to the part in an assembly view, and it contains a number that is that part's entry in the bill of material table. We have two ways of ballooning, manual ballooning and auto ballooning. For the manual ballooning, select the balloon, set it to one character, and select each part you want to label it. This one, this one, this, and this one. Each balloon automatically assigns a unique number to that part. So let's select one of them, and in the property manager I can do a little bit more. For example, I can change the shape from circular to triangle, hexagonal, box, diamond, or for example I can change the size to one character, two character, and you can change the balloon type if you want to, for example switch it to text and label it with names. And the quantity shows how many of that part exists in the assembly. I can place it on the right, left, top, or below. And in more properties, I can change the leader style. For example, change it to curve to give it a softer look. And then confirm it. The second method is auto ballooning and it's much faster. Let's delete these balloons. So let's select the auto balloon. And first you need to select the view that you want to add balloons to it. I think the exploded view is good. In the pattern type, I can change the style, for example, to top, bottom, left, right, or arrange them in a square or a circular around the parts. I think I go with the right pattern, and in the balloon settings, change the character to one character. I leave the quantity unchecked, I deal with it in the bill of material, and then confirm it. Once I confirm, the balloons automatically arrange and snap to a magnet line. So I can use this magnet line to change their position, or using these arrows to increase or decrease the distance between the balloons. And I think I placed them right here. And I need to change the other views right here. Anyway, let's create a bill of material. And for this, from annotation, go to tables and select bill of material. And top level only is okay. The item number start at 1 and increment is 1, confirm it, and place it above the title block. So the item numbers has correspond exactly to the balloon numbers. For example, if I select row number 1, the related part will be highlighted in the drawings. Let me decrease the size of the table and this one too. Okay, if you want to change the settings about the table, you need to click on these cross arrows above it. And for example, you can change the paddings, both vertical and horizontal, or you can change the alignment. And if you select this use document font, you can change the font as well and set it, for example, to 10. And now I can place it down here. If I open this column and hover to any of these rows, the related part will be pops up next to my pointer, super fast for checking. Now another thing is that you need to right click on the view and go to the properties and make sure link balloons text to a specified table is activated, and from the table select the bill of material. Now if I select the table and hit auto balloon again and select the view, there's a bit more I can do. For example, I can change the order and set the first item a different one, or I can follow the assembly order. So that was for the assembly drawing. I think we covered enough. Now let's move on to detailed drawing. Don't worry about the sheet format and title block just yet. We come back to them later and we learn how to customize them, save them, and have them ready for our future SolidWorks project. And we also see how to apply them to our current sheets. So let's add another sheet, and I need to click on this icon here. Again, the first step is to set up the views. So I need to go to View Palette and browse to select the base part and open it. So I bring the top view again, and I don't need to add other views. Instead, I use the section views. I think that shows more details. So cancel it. But let's add the isometric view and place it into the sheet, and I change it to shaded with edges. So let's create a section view. The point is that I have features in both directions. So let's start with the vertical section and place it right here and confirm it. As you can see, it doesn't give us any details about this feature here. In the situation like this, I need to create another section and place it on horizontal alignment and create a section like this. But this one doesn't give us any specific about these holes too. In situations like this, you can keep both sections in your drawing, but that's not a very professional approach. Instead, what a professional engineer does is to create a two-direction sections. And I change it to aligned. And the first point is at the center of the section, and the second one is vertical, and the third point on the horizontal direction. Confirm, and place it here. As I told you, the arrows always needs to point towards the section, and I need to flip it. And this one gives you a clear view of both directions in a single section. But if that's still a bit confusing, let's open the part. And I tiled it to left and the views on right. So go to the exact view of the drawing and create a section. Since we are seeing the part from above, the lower half remains. Confirm it, and I rotate it in this direction. Hold Alt key and click on the left arrow and change the display style to hidden lines. And this is what we exactly see in the lower half of the section. So let's go back and change it to shaded with edges, and again I'll go to the original view, and this time I create sections on the vertical direction, and it is okay. So I rotate it, and this is what I exactly see in the upper half of the section. The conclusion is that this aligned section gives us everything that these two individual sections do, but it is much more efficient. So I don't need these sections anymore. I can delete them. Now let's add the center lines, and from annotation select center line, and this one, this one, this one, and this one. And the center marks are here, I don't need to add them. Alright, moving on to dimensioning. The first method is model items. And for the source, select the entire model and leave the rest to the default and confirm it. As you can see, it brings a lot of information that they are messy, crowded, and overlap with each other. So let's say that I want to organize them. Grab them all, and next to my pointer, a shortcut appears, and from there, select the auto arrange. And you can fine tune the spacing using this wheel. Let's make it 1. Some of these dimensions, they are not even necessary, like this 1 dimension here or this angle. So while this method is handy for some simple models, it's not the best one for complex ones like this. Instead, we can use a smart dimension and add them manually. That way we can focus on important features that the software might not recognize on its own. So I delete them all, and I need to add the center lines and center marks again. For the center marks. Okay. I'll start by adding the outer diameter. So I grab this edge, and for a small quarter circle appears that they are for auto aligning. And I confirm it. And I add this diameter from here, select this edge and this one. And now we have 2 half circles. The right one put the dimension on the right side, and the left one put it on the left side. Next, let's dimension the central hole. So notice how SolidWorks automatically adjusts the spacing between dimensions and always place the largest dimensions farthest from the view, which keeps everything neat and readable. So I place it like this, and it goes here. And for this feature, I think I added on the other view, and I select this edge, place it down here, and it shows the radius. If you want to change it to diameter, go to the leaders and select the diameter. Of course, you can change the style if you want to, and confirm it. Also, I need to dimension this hole. Just be advised that the inner circle is the hole and the outer one is the chamfer. So select it and place it down here. Can bring it up. It would be like this. Now it's time to add the spacing. So this hole and this one, put it down. This one and this one, put it on the left. But we need to show that they are symmetric around the center, and one way is to add another dimension between this hole and this one. Another thing that I usually do is to select the 50 dimension, and in the dimension text I add 2 equality sign before and after the dimension to say that they are symmetric around the center. You can do a little bit more here. For example, you can add tolerance and precision, which we'll cover in the next session, or you can override the value, but I wouldn't recommend you to do that from here. If you actually need to edit one dimension, you need to do it directly from the part. And in the dimension text, you can add names, letters. For example, you can put it inside the parentheses or mark it as inspection dimension. And down here, we have some symbols. For example, diameter, degree, minus, plus, square, countersink, counterbore, depth. And if you want to add them, you need to go to that position and add them like this. So right now our dimensions are displayed with 2 decimal places. Since the tolerances usually require 2 or 3 decimals, I would prefer to keep the main dimensions a little bit cleaner. And for this you need to go to the options, under document properties, select the dimension, and from primary precision, the first one is for the main dimension and I set it to 1 decimal place. And the second one is for the tolerance precision and I put it on 2 decimal places and then confirm it. Earlier I mentioned that you can override the value directly from the part. If you want to edit one of these dimensions, you need to go directly to the part and let's select the Boss Extruded 1 sketch and change 100 to 101. So if I minimize it in the drawing, it is 101. Let's go back and bring it back to the original dimension, which was 100. Sometimes though, you run into small features in your drawing, details that are hard to see on the paper sheet but still as important as the rest of the part. For example, let's say I want to add dimensions for this chamfer, but it's too small on the paper. What I can do in situations like this is to add a detail view. From drawing, select the detail view and draw a circle around the feature and place it down here. You can change the scale if you want to, but I think it's fine for me. And for the chamfer, under Smart Dimension, select the chamfer dimension. First, select the chamfer itself and then a baseline. Place it down here. Another thing you should understand when creating technical drawings are 2 main dimensioning methods, chain dimensioning and baseline dimensioning. So chain dimensioning is a method where each feature is being measured from the previous one, like links in a chain. So from the dimensions, select the chain dimension and select the edges one by one. Would be like this. The view is too small. Let me open another example. So let's go to SolidWorks tutorial and Unreal. So this one is good. Let's delete these dimensions. So in chain dimensioning, as I told you, each dimension is being measured from the previous one. Just like this. And they are totally aligned with each other and they move with each other. The main issue with chain dimensioning is tolerance stack up. Each one of these dimensions has a small allowed variation, and those variations add up along the chain, resulting in big deviation from the nominal size of the part. We use chain dimensioning when tolerance stack up is not critical, or overall spacing is not as important as the spacing between features. If you want to prevent tolerance accumulation, you need to use baseline dimensioning, or sometimes called datum dimensioning, which is a method where all dimensions originated from one single common reference line or point, called datum or reference. So let's delete these dimensions, and from dimensions select the baseline dimension, and the first thing you need to do is to select the baseline and then add the features one by one. So instead of each feature being measured from the previous one, they are all taken from the same baseline, just like this. Another cool thing is that you can convert baseline dimensions and chain dimension back and forth. Super easy. Just select dimensions, right click, and convert to chain. Or you can do the opposite. Select them all and convert to baseline. SolidWorks absolutely nailed it when it comes to making these tools quick and easy to use in drawings. Anyway, in our model, I would prefer the baseline dimensions, so I grab them all and convert them to base, just like this. Now let's add the hole sizes. These holes were created by using the hole wizard, if you remember. And to call out their details, I need to go to Holl Callout and select one of the holes. I place it right here The note tells us there are two identical holes with a diameter of 3.3 and the thread size of M4, and the depth goes through all. And we have two another holes on this side, so I grab the edge, place it up here, and it is exactly the same. So let me add this dimension too. And organize the views and the notes, something like this. So that wraps up dimensioning. In the next session, we'll take things to the next level and learn how to apply tolerance and GD&T. We also customize the title block, add notes and surface finish, drawing option and settings, break view, and cool things like format painter. If this video helped you out, hit that like button and subscribe for more SolidWorks tips and tutorials. Got a topic you'd like me to cover? Drop it in a comment. Thanks for watching, and hey, don't stop here. From one engineer to another, keep practicing, keep learning, and I'll see you in the next one.